Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called One of the Tude by Oscode. And here are the rules. I placed a bunch of constraints in my puzzle, but I was stupid enough to use the same colors for similar looking constraints. Can you help me check if the puzzle is still solvable? I know that normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 without repeats in any row, column, or box. One of the cages contains 1, 5, and the other digits sum to 15. So one is a look and say cage, and one is a killer cage. That adds up to 15. So one of the cages is a look and say cage, which contains 1, 5, right? 1, 5. And then the other cage is a killer cage, which adds up to 15. One of the red lines contains a set of distinct consecutive digits in any order, which is a Renban line. And the other, while adjacent digits on the other line must differ by at least 5. So that's a German whisper line. So one of the lines, red lines, is a Renban, and one of the red lines is a German whisper line. We don't know which one is which. Okay. Along one of the dark blue lines, digits read the same from either direction. So that's a palindrome line. While any three adjacent digits along the other blue line must have different remainders when divided by 3. So those are a modular line. Okay, let me see. Should I give examples? So for examples of the Renban, okay, the cage is simple. One of the cages must contain 1, 5, and the other cage must add up to 15. For the red lines of a Renban, you could have something like, say this, we determined this was the Renban. Then this could have something like 3, 6, 4, 5, 2, and 1. Because the Renban has to contain a set of distinct, so no repeats, consecutive digits in any order. And for a German whisper line, if this were a 3, this would have to be an 8 or a 9, because the difference between, we know that the only digits, which could be 5 or more away from a 3 on a German whisper line, is an 8 or a 9. So that's an example of a German whisper line. For the dark blue lines, digits read the same from either direction. So that's a palindrome line. So it reads the same going this way. So say we determined this was the palindrome line. It would read the same going this way as it did going this way. While any three adjacent digits on the other line must have different remainders when divided by 4, 3. So it's a modular line. So as an example, for these 3 digits, if this were to determine this was the modular line, this could be something like 3, 2, and 7. Because 3 is 0 modulo 3, 2 is 2 modulo 3, and 7 is 1 modulo 3. So those are all different when divided by 3 if you get the remainder. Along one of the light blue diagonals, no digit is repeated. So therefore, it's a just like there are no repeats on a diagonal rule set. While the digits in the other one sums to the same total in every region it enters. So it's a region sum line. So therefore, if this were determined, if the positive diagonal were to be determined to be the region sum line, then these 3 digits must add up to the same sum as these 3 digits, which must add up to the same sum as these 3 digits. Digits along one of the gray lines must increase from the digit in the bulb, while the digits on the other line must sum to the digit in the bulb. So we have one is a thermometer and the other one is an arrow. So if this were the thermometer, this would have to be continuously increasing from the bulb to the tip. So you could have something like 4, 5, 7, and 8 here, because it would be continuously increasing here. And then if these were this, the other one would have to be an arrow. So you could have something like 1, 2, and 1 adding up to 4. And then we have values of digits along one green line must lie strictly in between the values of the digits in the attached bulb, while digits along the other must sum to the same value as the digits in the attached bulb. So, for example, one is an in-between line, and the other one, I think, it's not split P. I forget what the other one, the other type is. Basically, they add up to it's essentially kind of similar to a region sum line, except that the regions are the digits in between the bulbs, and then the bulbs themselves are the sum to the same value as the digits in the attached bulbs. So for in-between line, you have to have digits that are strictly in between the digits in the attached bulbs. So you could have something like 3 and 7 here, and this could be like 5 and 4. Because 5 and 4 are in between 3 and 7. That would satisfy that if this were the in-between line. But if they were essentially the other type of green line, it could be something like 3 and 7 and 4 and 6. And this 10 would sum up to the same values as 3 and the 7. Sum up to. So that adds up to 10 each there. Okay. One of the orange dots separate two consecutive digits, while the other one separates digits in a 1:2 ratio. So these are the two types of crop key dots. One is black and one is white. So for example, if this were a 2 and this was the black crop key dot, this would have to be a 1 or 4 to maintain the 1:2 ratio. But if this were 2 and this was the white crappie dot, this would have to be 1 and 3 to be consecutive with the 2. So those are the possibilities for the orange dot. For one of the y's separates digits that sum to 5, and the other y separates digits that sum to 10. So this is a Vx. So if, for example, this were a 4, this would have to be, if this were a V, this would have to be a 1 to add up to 5. If this were x, it would have to be a 6 to sum up to 10. And that's how x and y, and that's how the different possibilities for the y's work. Plus, we have one orientation of the gray digits, the gray triangles contain even digits, and the other orientation contains odd digits. And that's just what it means. If you determine that the up arrows contain the odd digits, that means the down arrows would have to contain the even digits. And those are all the rules. That's a lot of them. It makes sense because you're choosing essentially 1 out of 2 for each set of rules. And if you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. What we know in the cages is that the 5 can never be outside the cage, because one is 1, 5. It's a look and say cage, and it has a 5 in it. And the other one has to add up to 15 with 5 digits. And the minimum adding up to 15 for 5 digits to add up to is 1 plus 2 plus 3 plus 4 plus 5, which adds up to 15. So 5 in box 7 and box 9 must be in the cage. 5 can never, though, be around a X or a V, no matter what. So 5 can never be in one of those scenarios. So 5 is either here or it's here. And it's here or it's here. Which means, where is the 5 in row 8? cannot be any of these cells because the 5 must be in the cage, and it can't be next to the X or V. And same here, can't be here because 5 has to be in the cage and can't be next to the X or V. So the 5 in box 8, or actually row 8, has to be one of these 3 cells. What is the minimum digit that has to be in this bulb? Well, sorry, what's the minimum? It has to be 1 plus 2 plus 1. So this is at minimum of 4. To be along the arrow, it has to be 4, 5, 6, 7 at minimum, and 9, 8, 7, 6 at maximum. So this has to specifically be 4, 5, or 6 here. So we know one of the red lines is a red band, which means it's 1, 2, 3, 4, 5, 6 in length. This is 1, 2, 3, 4, 5, 6 in length also, which means it must require a 5 on that red band. Well, on this red band, if this were to be a red band, 5 cannot be here because, again, the 5 in box 8 has to be one of these 3 digits. It can't be here because it can't be next to, it can't be, the 5 in the box has to be in the cage, so it can't be any of these. And it cannot be here because we have a 5 in that box. Therefore, this cannot be the red band. This has to be the German whisper line, which means this is the red band, which requires a 5 because we have 6 digits already in that red band. And the possibilities are 1 through 6, 2 through 7, 3 through 8, or 4 through 9. So this must be a 5 in one of these 2 cells. Can't be here because, again, the 5 is in the cage and it can never be outside the cage. Can't be here because the 5 has to be in row 8 and can't be here. So it has to be here, here. Can't be here because of this 5. So it must be here, which means this cannot be 5 in this cage. The 5 has to be one of these 2 cells, which means this can't be 5 here. Therefore, this must be a 5 here. This is a Renban, which means it must contain a 4 and a 6 on this Renban. What does that mean? 4 cannot be here. 4 cannot be here. 4 on this Renban must be either here or one of these 2 digits. Either way, these 3 cells see the 4, so they cannot have a 4 there. What does that mean? I'm not sure. Okay, what other ones do we have? Look and see cage. We have, interestingly enough, okay. Whichever cage that has the killer cage rule set, it must be 1 through 5. It cannot have 2 digits adding up to 10. So it must contain the V in there. Therefore, the X must be in the cage that's a look and see. Look and say cage. Well, what are the possibilities? If this were the 15 killer cage, 4 could not be in this box, so 4 would have to be one of these two cells, which means this would not be 4. This cell that's not good. This has to alternate between lows and highs here. But we don't know which is which. So we're going to mark this as yellow. We're going to mark this as orange. This is yellow, orange, yellow, and orange. We know it's a German whisper line. Huh. If this were the killer cage, it would contain all lows. And that would eliminate lows from being on this line. But we know this is the German whisper line. So this cannot be the killer cage. Therefore, this must be the killer cage and must be the digits 1 through 5. 5 cannot be here. 4 cannot be here. 4 can't be here. This is 6, 7, 8, and 9 here. These two digits cannot be consecutive. So it must be a 1 to 2 ratio, which means this is 6 or 8. This has to be 3 or 4 with it, which makes this 1 or 2. This is one of these two digits is a 4, so this cannot be 4. These two digits add up to 10. And these digits have to be consecutive. That's interesting. So this is 5 or 6. So this is specific. It could be 6, 7 down to 2. So we know one of these is a 4. Oops, not there. One of these two is a 4. These digits are consecutive, but we're not sure which. This is never going to add up with these digits to add up to 6. So this must be the high end of the thermometer. So this is 5 at minimum. That means this is 6 at minimum, so it can't be 5. This is at 7 at minimum. This is 8 at minimum then. This is 9 maximum, which makes that 8 maximum, which makes that 7 maximum. And these add up together to add up to 5 or 6. So each of these, this must add up. This could be 4. And these then have to be 1 through 3. This could be 4 because this could add up with 1 and 1 to add up to 6. But the other ones have to have 1 and 2 here at least. Okay. So 4 must be here. 4 is here. 4 then has to be one of those 3 digits. 5 has to be one of these 3 digits. This adds up to 10. This we don't know. This is a low. One of these is low. One of these is low. This could be low with it. Let's see. If this is low, This would have to be high, which would mean it's next to another high. One of these would be low, and then you would have another low here. So this would be, then the other remaining low could not be here, could not be here. It would have to be one of these two. So this would be low, this would be low. But we have a 4, and 2 out of 3 of these are low. So this can never be low then, because if this is low, that makes this high, which makes that high. One of these is low, one of these is high. This is low, and there would be 2 lows here, 2 lows here, and another low here, which would make 5 lows in general in row 9, which is not possible. So this can't be low, this has to be a high, which makes both of these low. Therefore, we have, this is a high, this has to be 6, 7, 8, 9, and this is 1, 2, 3, 4. This is 1, 2, 3, 4 also. It cannot have a 4 here, because that would force this to be 3. This is also a low, actually. But this can't be 4, because if this were 4, that would force this to be 3 next to it, because these are consecutive. And that would eliminate all possibilities for that cell. So this can never be 4. Therefore, we have a 1, 2, 3 triplet, actually. This also has to be a 5, because there's no other place for the 5 in this row. So the yellows have to all be highs, because we have all the lows in row 8. The oranges must be low, and this must be a 4 specifically, which means it's next to a 9 on the German whisper line. This can't be 4 because it's a high. Well, where is the 4 on this Ren band? It has to be here. Therefore, this is a high. It's has to be, actually, it could be anything. So it could be 6, 7, 8, or 9 here. These two are high. This is a low. So this is 1, 2, or 3. This must then be 4, and this is 8, which makes this a 1. This can no longer be 1 here, and this can't be 1 or 4. This can't be 4. These are the lows, and this must be a low too, which makes this a high. So these are all highs. These are highs, which means this can't be 9. This can't be, none of these could be 8, so therefore this is a 9. This can't be 8 or 9. This can't be 8 or 9. This can't be 9. Where is the 9 in box 8? It has to be here. So this is 9, which means these digits are 4 through 9 to form the Ren band. So this is 8. This is a low. One of these is low, but the other one's a 5. This can't be 1. This has to be 6, 7, or 8 here. This is a high. This is low, low. And this is high. This is a low, but it could be any of them, 1 through 4. One of these must be a 2, because you can either have 1, 2, or 2, 3 to be consecutive. 1 and 3 cannot be consecutive. So this can't be 2, and this can't be 2. You can't have, one of these must be 1. To add up to 5, if this is 1, this is 1, 3. You can't have a 3 here, because that forces this to be 1 and 2 at minimum, and that adds up to 6. You can't have a 3 here, same thing. So this has to be 1 and 1, which must add up with a 3 to add up to 5. Therefore, this can't be 3. This is 2, which means this can't be 2. This is a 3, 5 pair, which makes this a 2. This is 6, 7, and 8 here. This can't be a 1, so it's a 2, 3, 2, 3 pair here. We have a 3, 5, 3, 5 pair here. The remaining digits in column 1 are 3, 6, 7, 9. Let's see. Remaining digits in column 6 are 4, 5, 6, 7, 8, 9. But this cannot be 4, 5, or 8. Oh, that's interesting. So, two of the ups are odd and two of the ups are even. We also have 4 and 8 which are even, which means the remaining digits in that are not up arrows or down arrows have to be odd. So this cannot be 2 or 4. This is 1 or 3. This cannot be 2 or 4, but it could be 1, 3, 7, or 9. It can't be 9 because of the 9 in the column. So this is 1, 3, or 7. Okay. 5 cannot be here, as can 9. Mm. Where can a 2 be if the down arrows are even? Well, can't be here. It must be here. So this is either 2, or it could be 1, 3, 7, 9, which is quite a wide variety. If the up arrows are even, either one could be 2 or 6. So there's no variety there. Hmm. Either this digit or this digit is the same as that. We're not sure which. Either this digit or this digit is the same as that. Okay, either way, going in on the diagonal, one of them has no repeats, but they both see a 1. So either the sum is the same here as the same here, or this is no repeats on this diagonal. Either way, this cannot be 1 because it sees a 1 that way and it sees a 1 that way. And one of them is the no repeat one. So this is 3 or 7. Hmm. Read the same, either direction. So we've got the red lines done, essentially. We've done the cages. We don't have the dark blue line yet. Hmm. We don't have the blue diagonals done yet. We do have the gray lines increasing, so that's good. We have the thermometers and the arrows. Green line, we don't have the in-between. Or the add up. Orange dots we do have. Y's, oh, this has to be 2 or 3 with 7 or 8 here. Interesting. This is a 1 to 2 ratio. We have the dots. We have the X and Y's. Or, sorry, the V's and the X's. And we don't have the triangle. Okay. Hmm. Uh, what else do we have? What are the actually? What are the remaining digits in column 5? That's actually interesting. We have 1, 2, 3, 4, 6, 7, 8. Huh. Interesting. Hmm. Interesting. Okay. What does that mean? I'm not particularly sure. Well, one of these must be 5, but this can't be 5. So one of these is a 5. Okay. So one of these is a 5, but it cannot be duplicated here. So the 5 is on the blue line. That is the modular line. So this modular line, this cell, whatever it is, either the 5 is here or the 5 is here, but this modular cannot be 2 mod 3 because 5 is 2 mod 3 and it's in the next cell on the modular line because, again, it cannot be a palindrome because then this would have to be 5 also. So this cannot be 2 or 8 here. It has to be 1, 3, 4, 6, or 7. Similarly, this can't be 2 or 8 because it would require that to be, you have 3 digits, which have to have, on the modular line, 3 consecutive digits on the modular line, must have 1 from each set of, sorry, they have to have different remainders. So 2 and 8 would have the same remainder on the modular line as the 5. So this cannot be 2 or 8 either, which means this has to be the 2 modulo 3 here. And therefore, this must be a 2 or an 8. That's interesting. So one of these digits is 2 or 8. We're not sure which. Well, this can't be 8, so if this were 2, it could be there. One of 3 or 6 has to be here. And one of 1, 4, or 7 has to be here. Hmm. Hmm. Let's see. What are the remaining digits in row 5? It's 1, 2, 3, 6, 7, 9, right? This can't be 9, though. Um, 'Not helpful there. 8 has to be one of these 3 digits here because we have an 8 here and 8 here. Hmm. Hmm. If this is a region sum line, you have to add up to 18 at least. Either way, this cannot be 1. And I don't think this can be 1, right? Along this line. Because if it's a no repeat, obviously you can't have a repeat on the 1 on the line. And if it's not no repeat, it adds up to 18. And this digit can't be 1 at least, because it needs an 8 and a 9 to add up to 18. So 1 could be any of these 4. We're not sure which. Hmm. One could not be here, but one could be one of these two. Maybe with 1, 8, and 9. That's possible. Hmm. Um. Hmm. Kind of limited right now for where we can attack. Hmm. Oh, this can never be 8 or 9. If this were 8 or 9 here, it would have to be as a palindrome. And this can never be 8 or 9 here. So as a palindrome, it could be 4, 6, or 7 here. So this could also be 1, 3, 4, 6, or 5, 6, or 7. 2 cannot be here. That's interesting. So where is this 9 then in box 5? Can't be here anymore because these two, if it's not a 5, it must be a palindrome with this digit, and 9 can no longer be there. Can't be here because the 9 sees it. Can't be any of these because the 9 sees it. Can't be here because the 9 sees it. So it must be one of these two digits. So we know the odd even pair here has to be 5 and 9. Sorry, the odd pair in 5 of these two digits have to be 5 and 9 because they're in essentially the two spaces that odds can be. And therefore the rest of the odd digits cannot be in these triangles, right? Because two of these are odd and two of them are even. But the odd pairs always has to contain 5 and 9 because there's no other place for them here or here, right? Therefore, you can remove all of the odd digits in those four spaces. So this cannot be 1, 3. You cannot have 7. You can't have 7 here. You can't have 7 here. It's supposed to be 5 or 9 here. So this cannot be 1 here. Where is the 1 in box 5 then? It can't be here again because this cannot add up to 18 with a 1 here. And it also, if it's a no repeats, obviously can't be here. It has to be one of these two digits because this can't be 1 because of that 1. 1 cannot be in any of these four spaces, so it must be one of these two. So this cannot have a 1 here. We also know this digit as a palindrome must be a 4 or a 6. because it corresponds to the 4 or 6 that would be here, which would be even digit. Hmm. Interesting. So this cannot be 9 here. Hmm. Um. Hmm. This is odd. Can this ever add up to 15 or 18 is the question, right? Mm, hmm. If this is 2, this would have to be 8, and therefore this would be 3. So this would add up to 12 in that instance. If this is 3, this is 7 and 2. So this would add up to 10 in that instance. So either it adds up to 10 this way or 12 this way. It can never add up to 10. Right? 3, 4, and 5 at minimum would have to add up to 10. So it would be 3, 4, and 5 if that were the case to add up. Therefore, this would be 3 and 7, which is no, sorry, 3 and 8, and this would be 2. That's possible. 1, 3, 8, 3, 5, 4. Um, hmm. Which would make this 6. So 1 of 2 or 8 is here. We know that for certain, because these cannot be 2 or 8 here. What are the other possibilities? Then one of these is 2 or 8, but it could be 8 here, right? Heck, it could be 8 here. We know 1 is one of these 2 digits. 3 has to be this here or these 3 or that one. Hmm. Can this add up to 15? Sorry, 18. I mean, it seems like it could. You could have 5, 7, and 6 here. Hold up. That doesn't work. If this is 5, this is 7, this is 6. But then this would be 9, and these would be both odds here, which is not allowed. because they're different sets. Yeah. How many ways could this add up to 18 is the question. You could have 3, 6, and 9, but that doesn't work because that would eliminate all possibilities for that cell. You can't have 3 with any of 4 or 5 to add up to 18, because that would require at least a minimum of 10. 7 with 4, that's 11. You would have to have another 7, so that doesn't work. Again, if this is 7 and 5, that would make this a 6, but then that would force this to be 9, and these are different sets. One is odd, one has to be even. So that's not allowed. And if you tried 7 with 6, that would require 5 to be here, which is not allowed because of the 5 in the row. So this cannot be the region sum line. Therefore, this must add up to 12, and this is the region sum line here. And it must add up to 12 here, which forces this to be 5, this to be 3, and this to be 4 to add up to 12. Therefore, this is not the 5. This has to be the palindrome. This then must be a 2 or 8. This is a 3, 4, 6, or 7 to match this palindrome. This can't be 3 actually anymore, so this can't be 3. This can't be 4, so this must be a 6, which makes this a 9. Therefore, this must be a 2. So the ups are the evens, and this is a 2. This cannot be 2. This must be a 6. This 3 means this can't be 3, so this is 1. This can't be 1 or 2, 3, or 2, so this must be 7. So the downs are the odds. The ups are the evens. This is 6, which makes this a 6 as a palindrome. So this can't be 6. This can't be 6. This is a 3. So it's 6 divided by 3 is 0 mod 3. Therefore, this is a 1 mod 3. It has to be 1 because it can't be 4 or 7. Therefore, this can't be 1. Because we have a 2 mod 3 and a 0 mod 3 in these 3 cells. This must be a 0 mod 3, and it can't be 6, so it's 3 or 9 here. This is 4 or 7, that's fine. This can't be 2, 3, or 6. This can't be 6 either, so one of these 3 must be a 6. The remaining digits here cannot be 1, 5, 6. It could be 2, 3, 4, no 5, 6. Could be 7 or 8, though. 2, 3, 4, 7, 8, which means 6 has to be one of these 3 digits here. This can't be 6. Where is the 6? In box 9, it must be here. So this is 6. These 2 must add up to 11 with the 1, so therefore this must be 3 and 8. That makes that a 2, which makes that a 7. This cannot be 2 or 8. Well, where is... this has to be a 1. This can't be 4 anymore because of the 4 in the box. This is 7 or 8, but it cannot be the 8 because there's no repeats on this line. So this must be a 7. The remaining digits on this diagonal are 2, 4, and 5. And this can't be 2 or 5, so this must be 4. The 5 has to be one of these 3 cells, so it has to be here, which makes this a 5, and this must be a 2. 6 can no longer be here. 4 and 9 can no longer be here. We have a 5, 7, 8 triplet in box 2, which eliminates 5, 7, 8 in the rest of the box. This can't be 7 then, which makes this a 4. This can't be 8, so this must be 2. This can no longer be 6. Where's a 6 in... Where's a 7, actually? The 7 cannot be either of these cells because of this 7. So this must be 6, this must be 8, this must be 7, which makes that an 8. That makes this a 2. This is a 4 to make the palindrome work. This can no longer be 4. This is 3 or 7. This is 3. Okay, so this is 3 or 7. which means this can never be between line because there's only one digit that's in between 5 and 3 or 7. So this can't be 3, 7, and this would be 3, 7, or 8 as possibilities. So this must be an 8. This is 3 or 7. Therefore, these two digits must add up to what these two digits add up to. Well, if you have 3 and 5, you could have 1 and 7 here, so that could work. The remaining digits here are 3, 6, and 7, essentially. 5 cannot be here. 4 cannot be here. This has to be an in-between line here. So this can't be 6 here. We also can't have a 9 on an in-between line because 9 is never in between two other unique digits on a normal Sudoku puzzle. If this is 5 and 3, this would have to be 1 and 7. If this is 5 and 7, it would have to be 3 and 9. So this can never be 6 here. Where is the 6 in column 9? It has to be here. So if this is 5 and 3, this is 1, 7. If this is 5 and 7, this has to be specifically 3 and 9. Okay. Remaining digits in column 4 are 1, 3, and 9. Okay. This must add up to 12 here for these three digits. Also, we know one of these is a 2, and then we have, this can't be 7, actually. There we go. So we now have a 3, 9, 3, 9 pair in row 4, which eliminates 3 and 9 in the rest of the row. That makes this a 7, which forces this to add up to 12. So this is 3 and 9. That eliminates 3 and 9 in the rest of the row. Therefore, this is 1. This can't be 3. This must be a 7 in between these two digits. So this can't be 7 anymore. This can't be 7 because of this 7, so this is 3. The remaining digits here are 2 and 6. This 7 means this can't be 7, so this is 6, which makes that a 7. This 6 means this can't be 6, so this is 2, which makes that a 6. Remaining digit here is a 1. Remaining digit here, this can't be 1. Remaining digit here is 7 and 8. Well, we have a 7, 8, 7, 8 pair in row 2, which eliminates 7 and 8 in the rest of the row. And this can't be 7 anymore because of this 7. This can't be 8. Remaining digits are 2. These can't be 4. So 4 cannot be either of these cells, can't be here, it must be here. 2 cannot be here, or here, or here, or here, so this must be a 2. Then we have 3, 6, and 9 here. So this is 3 and 9. This can't be, no, sorry, we're missing a 1. This has to be 1, because this can't be 1 here. So this must be 1, and it must be between 1 and 9. So this, to have 4 and 7 in between. So this is 9, this is 3. This can't be 3, 6, or 9, so this is 3. This can't be 3 or 9, so this is 6. These three digits must add up to 12, so this must be a 5, which makes that an 8, which makes that a 7, which makes that an 8, which makes that a 7. Therefore, this is a 5. This 3 eliminates this 3, so this is 9, this is 3, this is 8. This has to be 9. This 3 eliminates that 3, so that's a 5, which makes that a 3. And that's a solution. Interesting. Yeah, I mean, I'm not sure what to say about it. It's actually, it's an interesting concept which I've seen done before. And this was pretty well done, actually, I will say. The logic behind it was solid for every step, and I didn't really feel like I was lost anywhere along the way. Good job. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.